Hello everyone, this is me Vinhilson. Welcome to my third GIS tutorial. At first, let us check our today's content. Today we'll learn about the basic concept of georeferencing, spatial referencing, geographic coordinate system, projection, projected coordinate system, projection parameters, distortion, defining projections of a shapefile, and lastly we'll learn how to transforming the projection of shapefile. What is georeferencing? Georeferencing means that the internal coordinate system of a digital map or aerial photo can be related to a ground system of geographic coordinates. What is coordinate system? A coordinate system is a reference framework that defines the position of features in either two or three-dimensional space. There are mainly two types of horizontal coordinate system. Number one, geographic, and the number two, projected coordinate system. Geographic coordinate system. A geographic coordinate system is a three-dimensional reference system that locates points on the Earth's surface. The unit of measures is usually decimal degree. A point has two coordinate values, latitude and longitude. Projected coordinate system. A projected coordinate system is a flat, two-dimensional representation of the Earth. What is projection? Projections are a mathematical transformation that take spherical coordinates, latitude and longitude, and transfer them to a xy planar coordinate system. What is distortion? A distortion is the misrepresentation of the area or shape of a feature. There are no map projections that can maintain a perfect scale throughout the entire projection because they are taking a spheroid and forcing it onto a flat. Okay, now we'll learn how to define a projection of a shapefile in ArcMap. We'll go to the ArcMap. Here in ArcMap, we will add a shapefile from our add data. Let's say this is our shapefile, water body. Okay. Now, if we go to its properties, we can go in properties by right click and go to properties, or we can go just simply double click on it. In the properties of this shapefile, we can see the projected coordinate system of this shapefile is BTM. If we want to create a new projection of the shapefile, we have to clear it first. For that, we have to go to the arc toolbox. It's loading. From arc toolbox, we will go to the data management tools, and then we go to the projection and transformation, and here we will find define projection. We'll double click on it. Now here you can see there is two field: input dataset or feature class and the coordinate system. If we input our shapefile here, it is showing that coordinate system of this is BTM new. And if we want to clear it, we have to go to here. In this part, there is a icon like globe. Here in this drop down menu, we will find clear option. If you clear, there is no current coordinate system here. If we want to add a new coordinate system, we'll go to here again and into this section new and projected coordinate system. Here we'll give a new name of this projection coordinate system. Let's say we want to project this shapefile in BTM, Bangladesh Transverse Marketer, and here we can see some parameters: false northing, central meridian, scale factor, latitude of origin. Every projected coordinate system has its own false northing, central meridian, scale factors, and latitude of origin. Let's say for BTM, the false sting is 5 lakh. Let's copy from here and paste it here, and the false northing is minus 2 lakh. Copy it and paste it here, and then central meridian is 90. copy and paste it here. And the scale factor is 99. Now we'll learn how to transform the projection of a shapefile. And the scale factor is 0.9996. We'll copy it from here and paste it. Okay. The latitude of origin is 0 here, and the linear unit is here meter, and meters per unit 1 meter. If we click it OK, we find our new coordinate system BTM and OK. Go to the properties now this of this shapefile. We'll see that the new projected coordinate system is BTM. It was before BTM new, now it is BTM. By this process we can set any projected coordinate system to any shapefile by giving the parameters of its own. Okay, now we will learn how to transform the projection of a shapefile. Now at first let's add a shapefile from here. Add data. Our shapefile is under construction building.shp. Edit. Now if we go to the properties of this shapefile, we will see this has projected coordinate system of BTM and geographic coordinate system of GCS Everest Bangladesh. Okay. Now if we open a new data frame from insert data frame, this is a new data frame. If we go to its properties, we will see there is no coordinate system currently. If we drag a shapefile into this new data frame, the data frame will have the default coordinate system of that shapefile. Let's see if we drag it to this. Now if we go to the properties of this data frame, we will see this has the coordinate system of this has the projected coordinate system of transfer market or BTM here, and the geographic coordinate system is GCS Everest Bangladesh. Okay. Now if we insert another data frame here, again if you go to its properties, there will be no coordinate system. And now we will set a coordinate system for this. Let's say we will set WGS 1984 UTM zone 45 north here. Okay, now this data frame is, and data frame has a coordinate system that is GCS geographic coordinate system. Now let's insert another data frame from insert data frame. This is our new data frame 2. It doesn't have any coordinate system now. Okay, if we set a coordinate system for this data frame, let's see, we set WGS 1984 UTM zone 45 Newton here. Now this data frame has a coordinate system that is GCS WGS. GCS geographic coordinate system is WGS 1984 here. Okay. Now if we drag this shapefile to into this new data frame 2, there will be a pop-up of a warning that the shapefile and the coordinate system of shapefile and the coordinate system of data frame 2 doesn't match. We have to fix this by from transformation here, and we have to select convert from GCS Everest Bangladesh to GCS WGS 1984. This is the GCS Everest Bangladesh is the coordinate system of new data frame, and the GCS WGS 1984 is the coordinate system of new data frame 2. Okay, from here we will select Everest Bangladesh to 1937 to WGS 84. Okay, close. Now if we see the properties of this shapefile, we'll see it has its coordinate previous coordinate system till now GCS Everest Bangladesh, but we can work on it in this new data frame section. But if we want to permanently change the geographic coordinate system of this shapefile, we have to go to toolbox from here, then go to data management tools from here, and then go to projection and transformation and to project. We'll double click on it. Okay, now you have to input data and data set or feature class. This is our under construction building. Let's input it here. Okay, uh,
if we drag our shapefile here in input data set or feature class, we say it has currently input coordinate system is BTM, and we can select what we want in the output coordinate system. From here we'll go to here option. We want WGS 1984 UTM zone 45 Newton north. Okay. Now geographic transformation. From here we have to select from the transformation, that is Evers Bangladesh 1937 to WGS 84. Okay, there will be an error because we have to remove this from here. We will click on it and select cross, and this is okay. If now we click OK, our projection is converted into WGS from BTM. Let's go to the properties. Let's go to the properties. Here we can see this is now the projected coordinate system is now WGS 1984 UTM zone 45. This is how we can convert a projection coordinate system to another projected coordinate system of a shapefile. That's all for today. Thank you everyone. See you in the next tutorial. Thanks for your patience.